So good day everyone. Hi, I am Omshri and this project shows how I trained Gemma 3 1 billion parameters to produce explicit judge visible reasoning traces using Tunix native Google library for JAX and GRPO on a single Kaggle TPU session. So the goal is not like a benchmark accuracy but reliable strictly formatted reasoning that the judges can evaluate directly without hidden chain of thought or inference time fixes or any post-processing. So the core idea is that most open weight models can answer questions but they don't consistently show their work. So in this project, reasoning is treated as a first class learning objective, not a side effect, and the model is trained on the format that was mentioned in the hackathon page, which is this, like the opening and closing tags of reasoning and then opening and closing tags of answer. So if I start with the notebook, so this is the notebook. So at first we'll update all the necessary libraries, then we install Tunix and we update the Kaggle to the specific version that we need for this project, and then we download datasets. So all the datasets, if I list them, it'll be like JSMK8, then we have OpenOrca, then we have SkyQ, and we have Alpaca, we have OpenHermes. So all these datasets are publicly available and are downloaded from various sources, like from Kaggle itself, Kaggle's home library, as well as Hugging Face. So all these datasets have been used and they have been formatted in the hackathon necessary format. Like you can see, we have downloaded the ultra feedback also. We have Logic QA 2.0, that's from GitHub, and various other sources. So we have loaded all of them, and this is the pre-processing code block actually. So it takes all the necessary things of each dataset. Like each dataset has different structure, right? So it analyzes each dataset structure and makes them into the native format that is required for the hackathon. So if we go down, this is a long function, and going down, so this is the formatting page, and yeah, so these are the samples as you can see. So these are the samples that have been generated. The question has been listed along with the reasoning and the answer. So what we got to do is, now we got to transform this into the reasoning and tag, cause for the model that we got to train, we are using a prompt. So we got to train it inside the necessary format which is included in the reasoning tags, actually reasoning and answer tags basically. So we go down, and this is the combined dataset list, actually list 5. This is in the form of JSON file. So what we do is, we take all the individual data from this JSON file and convert them into the prompt necessary. So as you can see, this is the sample one, which is the input, and the question is given, the options is given, and if you can see, it has been converted into the format, actually the opening reasoning tag, then we have the closing reasoning tag, then we have the answer opening tag, and we have the answer closing tag. So this is what the format that has been needed for the hackathon by the judges. So we have converted it to that. So totally, if you see, we got 6,665 records in the dataset. Yeah. So what we got to do next is, we got to build training samples from this. So we got a bit more, we got to format it actually for the because there are MCQs also involved in this dataset. So what we got to do is, like for answers, so for those questions the answers will be like A, B, C, D. So we got to change them into the answers, and then it's a bit more of pre-processing that has to be done. And finally these have been listed actually. So after all this processing and filtering, we got 2,822 clean training samples. So next what we got to do is, we got to load the base Gemma 3 model. So what I'm doing is, I'm loading it from the Hugging Face. So the model, if you got to see, is Gemma 3 1 billion parameters instruction tune module. As it has been mentioned by the judges that only instruction tune modules should be used. So we got to use that model, and then we download all the tokenizer base and everything that have been needed for our fine-tuned model. So we gotta download that, and after downloading, this is our final training code that we gotta use. And this code, basically what we do is we got a two-stage training program actually. So it's like training is divided into 3 explicit GRPO stages. The stage 1 is the format lock. So in this stage the model learns that format is non-negotiable and partial credit also allowed, and it is only given for progress towards the correct XML structure that we have defined actually. So if you see this, just a minute, the prompt has to be somewhere. Yeah, so this is our prompt template that we have used. So this is the prompt. So we have given the format that has to be listed, and we have included the question tag actually. Yeah, and if we go above, the stage 2 is the quality enforcement tag step actually. So the basic thing that has to be done is the structure must now be correct in the stage 2. Exactly one reasoning block, correct tag order, minimum reasoning length should be more than 10 plus words. Penalties are softer to maintain stability for the third stage. So the third stage is basically strict mode. So it will be like only fully valid outputs are accepted, and any extra text or duplicate reasoning or banned patterns receiving strong negative rewards all are removed actually. So the model constantly learns it from a lower to a higher degree of correctness. And the thing is that we have constantly made this model for fine-tuning, like we have to adjust the rewards constantly for different types of errors. So what we have done is we have included a debugging module in this. So in the training itself, during the training, the code itself gives you the data, like how many samples have been failed. It will show you the data along with like it has been trained on 600 batches for the stage 1. So for each 100 steps it will list you what and all data has been failed and what has been corrected. I'll just show you that. Yeah, and just go along. It's a long code actually due to the debugging. So yeah, so if you see, yeah, so these are the so we have included many gates actually to ensure the correct structure of the XML that has been needed. And so you can see the sample 2, the gate is stage 1 no structure. So in this thing, the basic error due to which the reward was suspended was due to the XML structure was not followed. So if you can see, the question is truncated actually, and the completion, this is the output actually. So completion follows the output. So as you can see, there is no XML tags included, so that's why this has been failed. And if you just go down, for every 10 steps it gives the failed and corrected steps, and at the 100th step it gives you the complete overall report, like whatever. So if you can see, so gate failure analysis, so the correct gate structure, how many samples have it is 366 samples have been forwarded towards correct gate structure, which is the first core it was like the first core thing that has to be focused in phase 1. So that almost 366 samples, which on totally 400 samples were trained, and 377 were succeeded and 23 failures were there, along with the distribution of error. So what we did is we analyzed these errors, like there may be some errors in the dataset also, right? So we analyzed these errors and we improved our dataset, plus also we improved the rewards actually, so that any hard filters in the first gate itself, like in the phase 1 itself, if you go too hard, it won't go up to stage 3. So that's why we introduced the concept of partial rewards. So it continues all the way up to long stage actually. Yeah, so and if you can see, there are sample passing outputs also, like you can see how much reward has been given and what is the prompt, like it was the prompt, you must respond in this, and the question was truncated obviously, and then this is the complete output that has been given by the model. So in that in this way the model learns from its mistakes and it moves towards correctness actually. So as you can see, the function should take the radius of the cylinder as input and return the surface area of the cylinder, and yeah, so and you can see the answer tags are also correct, like the opening tag and closing tag. So in this way we have introduced correctness in our code actually, so for us to learn and for also the model to learn basically. So now if you talk about the parameters that we have used for training, let me just go up. So we have trained it for the 6 we had did a 2-phase training actually. Like what we did is we tried to use supervised fine-tuning, but what we observed was it was a bit naive towards this model. So what we did is we used two-phase RL. So instead of the first phase of supervised fine-tuning, we used somewhat similar time of reinforced learning, which has the num generations is 2 for the first one, because it can't be 1, because num generation has to be minimum 2 for the model to compare and learn. So batch size was 8, the max tokens were 386 and max generate tokens were 96, and the stage 1 end was 200 and stage 2 end was at 400 steps. These are other class that have been generated for debugging. Now if we go down, I'll just show you the configurations. So this is the rollout config for the phase 1. So as you can see, the max prompt length has been set. We had defined it already, we hard coded it, and we had the temperature has been set, the top k and top p values have been set, and as we know, the instruction to the hackathon needs us to use the instruction to module. So instruction tune modules, they are chat based modules, so they tend to give out end of turn tokens actually, so it's like hard coded in them. So our training is based on banning them actually, because for the first time we run the code, there were a lot number of tokens, like the max tokens are 256. So after the answer tag closes, almost or 100 end of turn tokens are generated. So as we are training not on the base GEMA 3 1B model, and we are training it on the IT model, so what we did is we have used the end of turn token to mark the end actually, and we got to block it actually because it creates a lot of junk tokens. So that has been used in the train rollout, and it's also used in the evaluation rollout. Both phase 1 and phase 2 it has been used actually. So moving down, so as seen, yeah, so these are some more statistics and things that we needed. And if we go down, let's just go skip all because it has been a very long step actually. So yeah, so if I just go up, so this is the final analysis that we have got. So at the phase steps 100, the success rate was 94.2, and each step we got to see the progress of the model in learning the structure and accuracy. So yeah, so that was the code. If we go down, so we also evaluated our model. I'll just let you show that. Yeah, so next thing what we do is we got to save the train model. So we got to save all the checkpoints and everything. So we create a directory, we save it over there, and what we do is, so as you can see, the metadata, OCBT, OurBags has been used to save the flag structure of the files. And yeah, so after that what we do is we upload the model to a Kaggle unrestricted site, so that judges can just load it and evaluate based on their functions and classes. Yeah, so now if we go up, so this is a simple inference that we have used for our own testing purpose. It's not a part of the model actually, but it's just for our own reference, that how the model is performing, how it is going and everything. So what we did is we tried to match it as the judges have mentioned. So as you can see, the inference temperature is 0.0, top k is 1 and top p is none, and max generation B have kept it 256. It can also go to 768 as per the judges. So we have kept it as more close to the evaluation of the judges actually, for us to have a better insight of what we are doing and what is correct and everything. So we load the Kaggle model, which is publicly listed. Then we also load the Hugging Face base model. We load it from Hugging Face, and then what we do is we download the checkpoint. We then we create a mesh along with the mesh parameter is 1:1, and then we restore the weights, then we train the weights, and then we use the vanilla rollout. And as you can see, these are the questions that we have tested it actually. So it's like core reasoning, the conceptual clarity, logic and common sense reasoning, everything has been used. So as you can see, this is the output given by our model, which has been downloaded from the public model listed on Kaggle. So the question is like, explain why having a backup plan is more important when making decisions. So this is the reasoning part, started and closes with the reasoning tag, and then we have the answer tag and closed with the answer closing tag. So this valid format true is our own it's our own function that we had made in the inference. It is not something emitted by the model, so it's just for us to evaluate the structure of the code actually. So if you go through another question, the same, the reasoning will be given, the answer will be followed. Now if we go through some more things, so yeah, you can see that why is it risky to rely on a single source of information. Now if you go for something like mathematical, just a minute. So if you go through some mathematical, it's like so this is a creative process, like in one paragraph explain why clear communication important in network and everything. So that's how it goes, and this is the final output that we have got. So just me go for a mathematical model. So as you can see, so what's 25%? To find 25%, you have to do this. You have to multiply by 0.5. This is same as converting the percentage to a decimal by dividing 100. Then you multiply the decimal by 200, and the final answer has been given 15% and everything. Sometimes the thing is that the mathematical answering is a bit incorrect in these models, and as the judges have already specified in the discussion that mathematics is not as good as compared, so I just included it as a test case for us, because we had a lot of time and so we just wanted it to do. So this is the final output, and this is our reference purpose actually. So this is our model, and this is what we have used. We have used three-phase reinforcement learning. And the key takeaway is that strong yearly format enforcement plus strange GRPO constraints can reliably train open weight models to show their reasoning. Like if you see, Tunix makes this practical and reproducible on Kaggle TPUs, as you already saw that. So it is in that case. So that's the end, and thank you for reviewing the submission. Thank you for giving us a chance for this wonderful opportunity of trying to reason an open source model, that too it's a Gemma 3 1 billion parameters. That's have been a very great experience for the whole month that I have been working on. Thank you.